Hello everyone, welcome back to my channel. Today we're doing another math lesson and we are getting loud because we are talking about volume, but we're talking about volume within geometry, which can still be pretty fun, even though it's not as loud as we would like it to be. So let's get started. Because I'm currently living within the state of Georgia, I will be using Georgia's core content standards in relation to today's lesson. So the standard relating to our topic today is recognizing volume as an attribute of solid figures and understanding concepts of volume measurement. More specifically, a solid figure which can be packed without gaps or overlaps using n unit cubes is said to have a volume of n cubic units. Now let's discuss this content standard because that was a lot of words that I just threw at you. So let's kind of break it down. So the actual legitimate somewhat definition of volume is the amount of space a three-dimensional object has within itself. So we can kind of think of this like a rectangular container and filling up that rectangular container, whether it be with solid or liquid, but in this case, they're going to be cubes, unit cubes, so that they're equivalent to cubic units, taking it back to the standard there. And you're just filling that container with no gaps, no spaces. It fills up perfectly. That is volume. And the amount of unit cubes it takes to put into said container is the exact same number of what the actual volume of the shape is as a whole in terms of cubic units. So this is basically just showing that you know how to calculate volume when provided with a three-dimensional shape. Typically, you're going to come across this when it comes to like rectangular prisms, much like rectangular containers or cubes. Now that we have discussed both the content standard as well as breaking down that content standard into simpler language, let's actually go over the vocabulary for this lesson. That'll help make certain things make more sense. So, like we discussed earlier, the definition of volume is the amount of space within an enclosed three-dimensional object, taking it back to that container example. A solid figure is a tangible object that can be measured by length, width, and depth, making it three-dimensional. So that also kind of pertains to that rectangular prism being seen as a container. That would be a solid figure. Cubic units, the units used to measure the volume in objects. So we're also going to show you a cubic unit in a little bit, but they're essentially just tinier cubes that show how the dimensions work. The definition of depth is the measured distance from the front to the back of a cubic unit or of a continuous solid figure. Dimension is a measurable aspect of a tangible object, such as length, width, and depth. So that's more so just speaking on the ways that we do measure volume, because we do measure it using the length, the width, and the depth of our solid figure. And a prism is a solid geometric measure with two equal ends that are rectangular and the rest of the sides being equivalent parallelograms. So this is basically taking certain shapes, certain 2D shapes, and then making them 3D. So we would have, instead of a rectangle, we would have a rectangular prism, to where that rectangle now has more sides and faces, to where it is three-dimensional as opposed to only 2 dimensions, which would be length and width. So a prism is simply a shape that now has depth, but that also makes it a solid figure. Now that we have gotten all that vocabulary out of the way, let's actually have some fun and start breaking down volume. So on the left of the screen, you will see a singular cubic unit, while on the right of the screen, you will see a cube consisting of other smaller cubic units. Let's start with just focusing on the singular cubic unit on our left. I have already broken down the different dimensions using different colored lines, and I'm going to explain them now. So we have 3 dimensions for a cubic unit, And those three dimensions are height, length, and depth. I represented height using the blue line. This typically just tells us how tall the unit is. So because it's a singular cubic unit, the height is going to be equivalent to 1 because it's only one unit. Same thing goes for the length, which is represented by that pink line at the bottom. And it literally just tells us how wide this unit is, and it's only 1 unit wide. And we use green to represent the depth of the unit, which, as we just discussed in our vocabulary, simply tells us how far back this three-dimensional shape goes. So when we do area, we only do units squared because there's only two dimensions that we're talking about, and that's typically just length and width. But here we have three. So in order to best explain that, let's kind of hop over to the picture on our right. In the picture on our right, you see that we have a height of 5, a length of 5, as well as a depth of 5 in terms of how many units make up that particular dimension. But instead of saying 5 times 5 times 5, which would be the formula for finding volume, height times length times depth, we have 5 cubed. And that's still correct. Because it's a cubic unit, we're multiplying all three dimensions. So instead of just doing 2, which would give us units squared, we do 3, which gives us units cubed. So by doing this, we're counting all dimensions and we're accounting for all the squares within the shape. I've always thought it to be a good idea that if we want to be right, we must also know how we can be wrong so that we can avoid being wrong. So some common misunderstandings about volume are that a lot of people tend to confuse it with area or use the two interchangeably or think that they're more related than they actually are. And they're not. Volume is actually different from area because area, like I said before, only focuses on two dimensions, and that's typically length and width, while while volume focuses on three dimensions, height times length times depth. So area focuses on strictly flat figures, which are two-dimensional, while volume focuses on three-dimensional figures, which are those solid geometrical figures that we talked about, like rectangular prisms and cubes and things of that nature. And a lot of people tend to confuse width and depth, which is easy to understand because they're used to measure visually, they seem as if they measure the same thing. But in terms of volume, width is actually more related to the length because the length is what measures how wide the unit is, while width does that same thing. Depth, unlike width and length, measures how far back that unit goes. So just remember, depth is how deep something is, while width is how wide something is, which is equivalent to length in terms of volume. All right, mathematicians, it is the moment we have all been waiting for. It's sample problem time. It's time to actually apply everything that we've learned this far, and we have learned a lot, and actually put it to use in solving a problem that asks for the volume of a prism or cube. So in this particular question, we have a rectangular prism, and thankfully it does show us what a unit cube is, but we already know what a unit cube is, so we know what we're doing. And much like anything in math, there are multiple ways to solve this problem. And I am actually going to show you two of my personal favorite ways in which I do solve problems that call for volume. All right, so the first method that we're using to solve is what I like to call the breakaway method, named after the iconic 2004 pop song by Kelly Clarkson. Feel free to look it up after this video, it's such a great song. So what I really like about this method is that it seems to work really well for those who learn visually because it allows you to see how the cube or prism is divided or how it's built. So with this method, we're actually going to break away different sections of the cube or prism in terms of their dimensions. So like in the picture on the left here, this what was once a rectangular prism is now been divided into 4 different sections based on its height. So we now see that it stood 4 units tall, but we can also see the other dimensions a lot clearer because it's breaking it up. So by breaking up this shape into these sections, you do essentially get a clear view of how many cubic units make up each dimension, even if you're only separating by 1. So when using this method, you typically only break away for 1 dimension. So like how here, they broke it up dependent on height. Now, because they broke it up dependent on only height, they can still solve for the other dimensions without having to do any more breaking apart. So with the breakaway method, it's a little easier if you just break it away for 1 dimension. And we're going to do that using all 3 individually. All right, everyone, I hope you are ready. Let's get started and into the breakaway method. First, we are going to start with finding our length, which I have made a nice little somewhat straight line indicating how we would find the length for this particular prism. So this is why a lot of people think that width and depth are pretty interchangeable, because a lot of people would see this and think that we're actually searching for depth, but we're actually searching for length, which in this case is equivalent to width. So because we split this in half, we get 2 new sections of the rectangular prism. So even though these 2 new sections, which I have attempted to highlight in the picture on the right, my drawing skills are not that great, but hopefully they're at least comprehensible. We have 2 now separate but equal sections. So because these sections are equivalent to one another, they're essentially the same. So when it comes to the breakaway method, all you're doing is counting the sections of which you've already separated. So because we're only separating for the length, we're only counting the sections in which we've already separated for. So we have our top half and we have our bottom half, meaning that there are only 2 sections to represent our length. So that means since we have 2 sections, the measurement for length is only 2. Now we're going to apply this same rule to find our height. So while we did split it down the middle horizontally to find the depth, we are splitting it vertically, which is more so up and down as opposed to left to right. We are separating it vertically to find our height. And then, just like last time, we are counting the amount of sections we have. So again, I try to create a straight line. This one looks a little bit better, still not perfect, but we will take what we have. And again, my shading for the picture on the right isn't as great as it could have been, but we will take it. So because we've separated our 2 sections, we can count them 1, 2. That means if we're using the same rule that we just applied to finding our length, that means that the measurement for the shape's height would also be 2. So now we can finally find our depth for our shape. And for this, we kind of cut it a little bit differently. We don't split it straight down the middle like we did for length and for height. But for depth, remember, the definition of depth is the measurement of how deep an object is. So we're literally just cutting at the sections that go back. So we've created about 4 separate but equal, as per usual, sections for this shape, meaning that the measurement of the dimension of depth for our rectangular prism would be, what is it? 4. You guys are geniuses. You guys are such geniuses. All right, everyone, we are almost finished. All we need to do now is put everything together. So we found our height, our length, and our depth. which we found to be our height to be 2, our length to also be 2, and our depth to be 4. So now that we have all of these measurements, we're actually going to put them into the formula to find the actual volume. So the formula for volume is height times length times depth, which all we're doing is putting in the numbers, and we know the numbers for all three. So that would simply be 2 times 2 times 4. And you kind of have a little bit of leniency on how you want to multiply this. I personally prefer to go from left to right and do 2 times 2, which leads into 4 times 4, which gives us 16 cubic units. But I also know some people like to do it a different way. In this case, you could also do the 2 times 4 first, giving you 2 times 8, which still leads you to 16 cubic units, which is a great way to check your work. Now that we've done the breakaway method successfully, clap for yourselves, my wonderful mathematicians. You guys are amazing. We're going to learn the second method that I like to use, and I call this the plug method because all you're doing is plugging the numbers right into the formula. So as you can see on the screen, the formula for volume is length times height times depth, which I did also mention during the breakaway method. But much like what we saw earlier in this picture, we have a height of 5, a length of 5, and a depth of 5. So because these are all the same number, you don't have to say 5 times 5 times 5. You can literally just say 5 cubed, which will give you your answer of 125. So let's try using this method to solve for our own rectangular prism. Now that we've had a chance to discuss the plugging method, let's actually use it to solve. So this is actually very similar to the last step of the breakaway method, except it's just a little bit quicker. It takes us to the solution a lot faster. So all we're doing is taking those same numbers that we found for our height, length, and depth, which are 2, 2, and 4, and simply plugging them into the formula. So again, the formula is height times length times depth, which once we plug it in is equivalent to 2 times 2 times 4. And like I said before, you kind of have a little bit of leniency on how you want to multiply this because regardless, you should still get the same answer of 16 cubic units. So I personally like to move from left to right, so I do 2 times 2, which then gives me 4 times 4, which then gives me 16 cubic units. But I also know a lot of people who would prefer to do 2 times 4 first, which would give us 2 times 8, which would still give us the correct answer of 16 cubic units. And there you have it, my wonderful mathematicians. We have done it. We have used two completely different methods to solve for volume of a rectangular prism. And these two methods can be put to any other rectangular prisms that you come across, and even cubes. So I hope you guys enjoyed this video. I hope you learned something new. And even if you didn't learn something new, I hope this was a great review for you. So be sure to come back to this video whenever you need some help with volume, and I'll see you guys next time.